All right, so day 1 and day 2 recap. Day 1 was mean value theorem. Again, lots of little details. We'll get to those in a minute. But like big picture, do you remember what mean value theorem says? Good. Calculus slope equals algebra slope. That's the main idea for mean value theorem. Now that's the conclusion to the mean value theorem. Let's build up to it, meaning there's two conditions that have to be met before you can conclude that calc slope equals algebra slope. Continuous and differentiable. So if f is continuous on closed, that's right, continuous on the closed. Step 2, f is differentiable on the open from A to B. Continuous goes with closed, differentiables on the open. The C's go together, continuous and closed. If that is true, do a little picture here. So there's a graph that's continuous and differentiable, simple one. Then the conclusion is the calculus slope equals the algebra slope. And really we should be a little more specific and say the calculus slope somewhere equals the algebra slope for the whole thing. So good old algebra slope. y2 minus y1 over x2 minus x1. That's algebra slope. Calculus slope, that's the new stuff this year. That's somewhere the tangent line is parallel to that overall slope. So somewhere the calculus slope equals the algebra slope, and that's somewhere where C is between A and B. Where C is between A and B. And your job is usually to find C. Like that's usually how the problems are arranged. So you find the algebra slope overall, you take a derivative, you set the derivative equal to the algebra slope, and you figure out where that happens, and you realize, hey, what do you know? It's in between A and B. So lots of detail, but the main point is that the calculus slope somewhere on the interval is equal to the algebra slope overall. That's MVT. That was way long ago. Day 2 had a ton of notes, but it sort of boiled down to this idea that if f prime is greater than 0, so if f prime is positive, what does that tell me about f? If f prime is positive, then what does that mean about f? It's increasing. And that's like in geometry, we'd say it's a bidirectional statement, like it works either way. If f is increasing, then that means the derivative is positive. If the derivative is positive, that means f is increasing. Like those are identical statements. And then the other one, if f prime is negative, then that means f is decreasing. This is where I hope I mentioned that this is not a memorize situation. This is like understand what derivative means. Derivative means slope. Well, if slope is positive, then you're going up, so you're increasing. If slope is negative, then that means you're going down, you're decreasing. So this isn't one of those things like you put on a note card and memorize and make flashcards out of. It's like, no, you understand what derivative means, and that tells you what the function is doing. We talked a little bit about critical points. Sure is.